This is a compliant mechanism that I designed as a visualization challenge. Given its complex arrangement of bent blade flexures, many students believe the mechanism's top handle is fully constrained to not move with respect to its bottom handle, but this is not correct. The mechanism can freely deform to guide a certain motion, which is surprisingly simple. Can you visualize what that motion is? Before you try, it may be helpful to recognize that the mechanism consists of two rigid parts that don't directly touch, despite this strange-looking circular feature, which appears to come close. The two rigid parts are joined together by two sets of three trapezoidal-shaped bent blade flexures attached to the front and back of the parts as shown here. Now that you better understand the mechanism's topology, I recommend you put the video on pause to visualize how it can deform and write your answer in the comments section below so everyone can gauge how difficult this challenge is for everyone else. Okay, if you're ready, the answer is that the mechanism achieves a single rotational degree of freedom about an axis that passes through the mechanism's center. I included this circular feature within the design to help viewers see how cleanly the mechanism rotates about its central axis. Although a fun visualization challenge, I don't recommend this mechanism as a practical rotational joint. It's bulky, relatively difficult to fabricate, and if loaded incorrectly with too large a magnitude, can exhibit unwanted parasitic deformations along its axial and transverse directions due to the fact that the bent blade flexures are not ideal, i.e., they don't behave as if the constraint lines that pass through their geometry are infinitely stiff along their axes or infinitely compliant in all other directions. If you want to get a sense for how the mechanism feels, I've posted part files to Thingiverse so you can 3D print and play with it yourself. Thanks for watching The Facts of Mechanical Design.